In level 3, we will be adding in reflections. So we will still be shifting exponential and log functions and then also reflecting them. So in this example, we have a negative sign on the outside. A negative sign on the outside is going to be a vertical reflection over the x-axis. A negative sign up by the x would be a horizontal reflection over the y-axis. So this is a vertical reflection which goes over the x-axis. And this graph is also shifting. Since we have a +3 by the x, that's a horizontal shift. And instead of going in the positive direction, we go back to the left. It's going to be a shift to the left 3. So since it's a horizontal shift, the asymptote is not going to move. It's going to stay on the x-axis. So I draw that in, and then I'm going to reflect this graph. Well, I'm shifting it 3 to the left. So my new starting place is 3 to the left, right here. It's like that's where I'm moving my origin. Now, normally, for my first point, I would start at the origin and go up 1, but instead of going up, I'm reflecting over the x-axis, so I'm going to go down 1. Right there. And then my next point would normally go right 1 up 2, but I'm going to go right 1 from my starting point and down 2. And then my next point is going to be right 2 down 4, right 3 down 8. And then from my starting point, as I go to the left, I'm going to go left 1 and then down half. And the graph will, as we go to the left, it gets closer and closer to the asymptote, never touches it. And there's your graph. I didn't really hit my points very well. But anyways, the domain of this function is still negative infinity to infinity. The range is now my lowest y value. Since it's going down forever, my lowest y value is negative infinity. And then my highest y value approaches 0. It will never hit 0, so I use a parenthesis. The asymptote is still horizontal, and the equation of a horizontal asymptote is y equals some number, in this case 0. The limit as x approaches negative infinity, as we head towards negative infinity on the x-axis, the graph is approaching 0. And as we head towards positive infinity, the graph is going down, so negative infinity. In this next example, we have a little negative sign by the x, so that's going to be a horizontal reflection. Which is over the y-axis. And it's shifting down 5 because we have a -5 on the outside. It's a vertical shift. Okay, in this one, the horizontal asymptote is going to move down 5 since we are shifting down 5. So I like to move my asymptote first. And then I'm going to reflect this graph horizontally. So normally my first point just goes up 1 from my starting place from the origin. That point is not going to reflect because it's on the y-axis, so it's going to stay where it is. And the other points are going to switch to the other side of the y-axis. So my next point would usually go right 1 up 2.7. Instead, I'm going to go to the left 1 up about 2.7. And then the graph will decrease and head towards the asymptote on the right. So the domain of this function, still negative infinity to infinity, will be for all exponential functions. The range, now my lowest y value is approaching negative 5, so I use a parenthesis, negative 5 to infinity. The asymptote is y equals negative 5, that's horizontal. All exponential graphs have horizontal asymptotes, and y equals for their asymptote. And then the limit as x approaches negative infinity, as we head towards negative infinity, the graph goes up to infinity, and as we head towards positive infinity, the graph is approaching negative 5. In this example, we're transforming a natural log graph. The negative sign is on the inside by the x, so that's a horizontal reflection. Which goes over the y-axis. And it's shifting down 2. Because the minus 2 is on the outside. Okay, so since this has a vertical asymptote, shifting it down 2 is not going to move the asymptote. So it's going to stay on the y-axis. So I draw my dotted line on the y-axis. And we are flipping it side to side. So it's going to be going this way. And also down 2. So what I like to do is change my starting place. So if I imagine moving the origin down 2, my new starting place is right there. And from there, I would normally go right 1, but since I'm reflecting side to side, I'm going to go to the left 1 for my first point. My next point would normally go to the right 2.7 and up 1. Instead of going right, I go left 2.7 and still up 1. And it lands about right there. Then we just connect and draw the correct shape of the graph. The domain of this function, the lowest x, it's going out to negative infinity on the x-axis. So negative infinity to the highest x is approaching 0 with a parenthesis. It'll never hit 0. The range of all log functions is negative infinity to infinity. The asymptote is vertical, and the equation of a vertical line is x equals some number, 0 in this problem. And the limit as x approaches negative infinity, as we head towards negative infinity, the graph is increasing, so it'll approach infinity. And as this little minus after that 0 is called a left-hand limit. So that means what's happening to the function as we approach 0 from the left side. And as we approach 0 from the left side, the graph is heading down to negative infinity. In this last example, we have a negative sign on the outside, so that's a vertical reflection over the x-axis. And we have two shifts. The plus 5 is a horizontal shift to the left 5. And the minus 2 on the outside shifts it down 2. So I am going to start by moving my asymptote. Since we're shifting to the side, left 5, I'm going to first shift my asymptote left 5. And we are also moving down 2. So my new starting place, from if I moved the origin left 5 and down 2, my new starting place is right here. And from there, my first point, which on my original graph is just over 1, when I reflect that point, it's not going to move because it starts off on the x-axis. So technically the reflection happens first, so that one's not going anywhere. So it's still just going to go to the right 1 from my starting place. My next point normally goes to the right 10 and up 1. Since I'm reflecting vertically, instead of going up, it's going to go down. So I still move to the right 10 from my starting place, and then instead of going up 1, I go down 1. So that gives us a point right here, and that point should be positive 5, negative 3 is the ordered pair. And this is what it looks like upside down. So it flipped vertically. The domain of this function is now negative 5 to infinity. The range is negative infinity to infinity for all log graphs. The asymptote for logs are always vertical, and it's x equals negative 5. The limit as x approaches infinity. As we head out to the right on this graph, the graph is decreasing, so the limit as x approaches infinity is negative infinity. And the limit as x approaches negative 5 from the right side, up here it's shooting up to infinity.